My name is Gulshan Banu, working as an assistant professor, AI and DS department. Today I am here to present you a topic called Uninformed Search Strategies. In the previous video, we saw some strategies based on the problem solving engine. So this is a new concept which is based on uninformed search strategies. What is this uninformed search strategies? Uninformed search strategy is also known as blind search strategies. Explore the search space without any knowledge about the goal beyond what is provided in the problem definition. These strategies do not use the domain specific knowledge and work purely by exploring nodes in the search space systematically. What is this breadth first search? The breadth first search explores all nodes at the present depth level before moving on to the node at the next depth level. It is a level order traversal of the search tree. So how it works? It starts from the root node, explores all the child node at the present depth level before it is moving to the node at the next depth level. What queue does it use? It uses the first in, first out queue. So what are all the properties of this search algorithm? It has the completeness of, it guarantees finding a solution if one exists as long as the search space is finite. The optimality is it finds the shortest path in terms of the number of steps if all actions have the same cost. The time complexity is big O of b power t, and the space complexity is also same as the time complexity. So what is the example of it? It is finding the shortest path in an unweighted maze or graph. Now, what is this depth first search? Depth first search, as I have explained you in the previous video, it explores as far down a branch of the search tree as possible before backtracking to explore other branches. It uses a stack to keep track of the nodes. So how does it works? Starts from the root node, explores all the child node recursively, dividing deep into each branch before backtracking. What it uses? It uses the last in first out process. So it also has the completeness, which is not guaranteed. Optimality does not guarantee the shortest path. The time complexity and space complexity of this is as follows. The example of it is solving puzzles or finding paths in a maze where paths are not equally weighted. What is this uniform cost search? Uniform cost search is a variant of BFS that considers the cost of reaching a node. How does it works? Uses a priority queue, and it starts from the root node, expands the nodes with the lowest past costs, and updates the cost of its neighbors. It also has the properties of guarantees the finding a solution in one exit, guarantees finding the least cost also. The time complexity is big O of b power t, and the space complexity is big O of b power t. Now, what is this depth limited search? The depth limited search is a variation of DFS that limits the depth of the search tree to the predictable limit. How does it works? It performs BFS up to a specific depth limit. If the goal is not found within the depth limit, it terminates. So what are all the properties? Here the complexity and optimality is not guaranteed. The time complexity and space complexity are as follows for this search process. The example for this is the searching for a solution in a tree while solutions are known to be within a certain depth. The iterative deepening search. Iterative deepening search combines the benefits of BFS and DFS by performing a series of depth limit searches, increasing the depth limit with each iteration. So how it works? Performs a series of DFS with increasing depth limits. Each iteration is a depth limited search with an increasing depth until the goal is found. So it also has certain complexities, optimalities, time complexity and space complexity. The completeness is nothing but the guarantees finding a solution if one exists. Optimality finds the shortest path. The time complexity is big O of b power t, and the space complexity is big O of t. What is this bidirectional search? Bidirectional search stimulates search from the start node and the goal node, hoping that the two search meet in a middle. So how it works? One search starts from the initial state and expands towards the goal. The other starts from the goal and expands towards the initial state. Stops when two searches interact. The complexity is it has some guarantees to find the solution. The optimality is it finds the shortest path. The time complexity and space complexity are as follows. Example for this is finding the shortest path between two cities on a map where both states' endpoints are known. So yes, these are the concepts of uninformed search strategies and the process of it. I hope you understood the concept, and I assure you that in the next upcoming videos I come up with a new video with a new concept and with a very interesting concept. So as of now, thank you.